Volcanoes are scary. They spew hot lava, ash, and gases into the air, destroying everything in sight. But they're also fascinating. How do they form? Where do they come from? And why do they blow their tops? To answer these questions, we went to the source, the very center of the Earth. Okay, not really. We just read some stuff. Here's what we found out. Volcanoes, by definition, are scary. They are ruptures in the crust of a planet or other celestial body that allow hot magma to escape onto the surface. Magma, which is molten rock found beneath the Earth's surface, can be pushed up by immense pressure, and when it reaches the surface, it's called lava. Oh, the hot lava flows out of the volcano in all directions, destroying anything that gets in its path. Hot lava flows, landslides, volcanic mudslides, and falling ash can travel miles from the volcano, leaving behind a trail of destruction. But volcanoes aren't always dangerous. Sometimes they're dormant for hundreds or even thousands of years, quietly sleeping until something wakes them up. Volcanoes can be found all over the Earth's surface, but they're most common along the boundaries between tectonic plates, which are the giant slabs of rock that make up the Earth's crust. The boundaries between these plates are often marked by deep cracks and faults, which allow magma to rise from the mantle, the layer of rock between the Earth's crust and core. As the magma rises, it collects in chambers beneath the crust, creating a magma chamber. When the pressure in the magma chamber becomes greater than the weight of the overlying crust, the crust ruptures and the magma is released. But why does the magma rise in the first place? It all has to do with the Earth's core, which is a hot, dense ball of metal and rock. The heat from the core radiates outward through the mantle, creating convection currents that drag huge slabs of rock along with them. These slabs are the tectonic plates that make up the Earth's crust. As the plates move apart, magma from the mantle can rise into the gap and solidify into new crust. This process is called seafloor spreading, and it's one of the main ways that volcanoes are formed. Another way that volcanoes are formed is through subduction, which is the process by which one tectonic plate is pulled beneath another. When two plates collide, the denser plate will sink into the mantle where it melts and forms magma. The magma then rises to the surface and creates a chain of mountains known as a volcanic arc. The Andes Mountains in South America are an example of a volcanic arc that was formed through subduction. But volcanoes don't have to be built along plate boundaries. Some of them are actually formed when magma rises from deep within the mantle in areas known as hotspots. Hotspots are areas of unusually high heat flow from the mantle, and they can remain stationary for millions of years. As the tectonic plates move over the hotspots, they create chains of mountains. Over time, the chains become so large that they form entire island chains. The Hawaiian Islands are an example of an island chain that was formed by a hotspot. Now that we know how volcanoes are formed, let's talk about what happens when they erupt. A volcanic eruption occurs when the pressure in a magma chamber exceeds the strength of the surrounding crust. When this happens, the crust ruptures and the magma is released. Eruptions can vary in intensity, from gentle lava flows to violent explosions that send ash and gas miles into the atmosphere. The type of eruption that occurs depends on several factors, including the composition of the magma and the amount of gas it contains. Magma that is rich in silica tends to be more viscous, or thick, which means that it traps more gas. When this magma erupts, the gas is released suddenly, which can cause an explosion. For example, Mount St. Helens, located in Washington state, erupted in 1980 in a powerful explosion that was caused by the release of trapped gas. The eruption was so violent that it blew the top off of the mountain and created a massive pyroclastic flow that raced down the mountainside at 186 miles per hour. On the other hand, magma that is low in silica tends to be less viscous, which means that it doesn't trap as much gas. When this magma erupts, it flows more gently out of the volcano. For example, Kilauea, located in Hawaii, is a shield volcano that has been erupting continuously since 1983. The eruptions are characterized by flowing lava rather than explosive activity. The amount of gas in the magma also plays a role in the type of eruption that occurs. Magma that contains a lot of gas is more likely to produce an explosive eruption, because the gas can build up pressure in the magma chamber, and when it's released, it can cause an explosion. However, If the magma contains only a small amount of gas, the eruption will be more of a lava flow. In addition to the composition of the magma, the shape of the volcano also plays a role in the type of eruption that occurs. Tall, steep-sided volcanoes are more likely to produce explosive eruptions because the rising magma has a long way to fall. This causes the magma to accelerate and generate more gas, which can lead to an explosion. On the other hand, broad, gently sloping volcanoes are more likely to produce lava flows because the rising magma has a shorter distance to fall. This means that the magma doesn't accelerate as much and doesn't generate as much gas. So now you know that volcanoes are formed by the movement of tectonic plates, the heat from the Earth's core and the composition of the magma. You also know that the type of eruption that occurs depends on the composition of the magma and the shape of the volcano. So next time you see a volcano, whether in person or in a movie, you'll know exactly how it was formed and why it erupts. For instance, you'll know that Mount Vesuvius, which famously destroyed the Roman city of Pompeii in 79 AD, is a stratovolcano. Stratovolcanoes are tall, steep-sided volcanoes that are formed by layers of ash and lava. They tend to produce explosive eruptions. Mount Vesuvius is a great example of a stratovolcano because it is tall and steep-sided and it erupted explosively, sending ash and pumice miles into the air. The ash fell over the nearby city of Pompeii, entombing it in a layer of ash and pumice. You'll also know that Mount Fuji, the iconic snow-capped mountain in Japan, is a composite volcano. Composite volcanoes are similar to stratovolcanoes, but they have a more significant amount of lava flows in their structure. They tend to produce less explosive eruptions than stratovolcanoes. Mount Fuji is a good example of a composite volcano because it has both lava flows and ash deposits. It last erupted in the early 1700s, but it is considered to be overdue for an eruption. Now that you know how volcanoes are classified, you can better understand the unique characteristics of each one. We hope you enjoyed learning about volcanoes. If you want to learn more about science, technology, engineering, or math, stay tuned for more videos. Thanks for watching.